As soon as I saw this free 3D printable file, I knew I could use it to help my students understand ratios and least common multiple, and it worked really well. So in this video, I'm going to share with you how this file works, and more importantly, how I used it in the classroom. If you are not able to 3D print these, or you're not able to 3D print enough of them by the time you want to do this assignment, I made a separate video is just of the gears so students can look at how many teeth are on each gear and walk through the assignment. And if you use my assignment, I actually put the gears in order of the assignment that I have in the video. So you'll just have to give them the 2-minute video and they can just walk, pause it, count however they need to, just like you are in here. But if you can, I do recommend 3D printing this because students seem to like it a lot more when you're able to make it a little bit more hands-on for them. About the file itself, before I move into the math. Essentially, it comes with an assortment of gears. The base itself is 3 pieces and they slide together. And then the idler gear will just pop in the middle. And then these little pegs here, they go in this little track on the base. And then as you can see on the bottom, I put a rubber band. And that rubber band allows it so when you have these different sized gears that they're able to still get pulled in to each other and still have their teeth mesh and line up. I also put a dab of super glue on there on the rubber band just to make sure that it doesn't fall off, because that can become a hassle taking tweezers and lining that up multiple times. But once I got that little dab of super glue on there, these rubber bands, everything's holding up pretty well. Let's move on to the math part. I'm going to do the very first one I have on my assignment, which is a 32 tooth gear and a 16 tooth gear. Now, one thing I'm going to show you right now, just in case students get confused, you can see that there's an arrow on the gear. You need to make sure they start lining up. So if they don't, I just pull this back, I rotate the gear, and then I move it so they are lined up. I have this 32 tooth gear, and this one I have on my assignment that it's going to be on the left side. So I'm going to spin this gear one time, and I'm going to see how many times this gear spins. So you can see that gear spun, the 16 tooth gear spun once, and now that spun twice while this one spun once. And I ended with these two lining up in the middle so I know I could stop. So as you can see, the left gear, it spun one time, and the right gear spun 2 times. Because I also wanted them to do part to whole, I included the total spins on here, which realize in industry they wouldn't normally do. So that would be 3 total spins. The left gear to right gear ratio would be a 1:2, because that's how many spins they did. The left to total would be a 1:3, and the right to total would be a 2:3. This may seem confusing to you at first if you are looking at the number of teeth. So if you look at a 32 to a 16, you would say that is a 2:1 ratio. But how we use gears in the real world or in industry, they're worried about the speed or how many revolutions it has. So even though this has 32 teeth and this has 16, this one spun once while this one spun twice. So this is a 1:2 ratio. Now, the next one on here was a 32 tooth to 8 tooth gear. And since you already understand ratios and least common multiple, you probably already know how many times this gear is going to spin. And as you can see, if I spin the 32 tooth gear one time, this 8 tooth gear will spin 4 times. So this one is a 1:4 ratio. Now this next one here is going to be a little more difficult. So this is a 32 tooth to 24 tooth ratio, or 32 teeth to 24 teeth. So we know this isn't going to line up after one spin. Now, if you understand least common multiple, you might know how many times I have to spin each of these. So I'll let you kind of think about it for a second, because each time I spin this one, like one tooth, this one's going to also move one tooth. After I start rotating these, when are they going to line up again? So we need to know what the least common multiple is between 32 and 24, and then we'll know how many teeth will have to be passing until they line up again. They're going to be 96. So This one's going to have to spin 3 times to get to 96. This one will have to spin 4 times to get to 96. And if we go to actually do this, and they're still not lined up, but then the third time, they are now lined up. This is the premise of part 1. I just have students put the different gears on, and they're going to count how many times they each revolve, and then they're going to end up practicing writing the ratio. So in part 2, I have gears that we do not have, and I did that on purpose. I wanted students to be able to do math to figure out what the ratios would be if we had those gears. Now, a lot of the times, you're going to have to go back to part 1 and re-explain to students, why did that one spin once when that one spun twice? And a lot of students will realize, like, oh, well, the 32 tooth gear is twice as big as the 16 tooth. It's like, okay, so that's why that one spun once and that one spun twice. So now let's look at the 30 tooth and the 10 tooth. How many times are they going to have to spin? Well, the 30 tooth one is going to spin once, and the 10 tooth one is going to have to spin 3 times, because the least common multiple between those two gears is 30. Now, if we go the second line, the 30 and the 20, the least common multiple between those two numbers is 60. So the 30 tooth gear would spin twice, and the 20 tooth gear would spin 3 times. That's essentially how this goes. Now, if you go to the next page, it's more of kind of a puzzle aspect. They're going to use the same math, and they're going to end up trying to solve all those different problems on there. Or I took out some information to see if they can figure out the rest of the information. But once they understand the concept of gears using these manipulatives, you're able to give them a lot of different types of projects and a lot of other different gear ratio problems. If you feel like your students would benefit from this or this assignment, I do have my Google Doc attached to this video. Feel free to make a copy, modify it however you would like. If you do like this type of content, make sure you subscribe, because I do have a lot more of these types of videos coming up. I really appreciate you sticking through this video, and if you have any questions, make sure you leave them in the comments. But thank you very much.